When a freight train is being assembled in a switching yard, two boxcars might couple when both are moving in the same direction and one overtakes the other. They might also couple when they are moving in opposite directions. We will analyze this second possibility, and we will consider the positive direction to be to the right. We will consider the case where m sub 1 and m sub 2 are both 80 times 10 to the third kilograms. V sub 02 is plus 0.80 meters per second, and V sub 01 is minus 0.40 meters per second. V sub 01 is negative, and this means that the car on the right initially moves to the left. The two boxcars constitute the system we will analyze. The weight of each car is balanced by a corresponding normal force. We will ignore friction, so the sum of the external forces acting on this system is zero. Thus, the system is isolated, and we can use the principle of conservation of linear momentum. Even though the boxcars are initially moving in opposite directions, the algebraic equation for the conservation of linear momentum does not change, but we will have to be careful about signs when we put numbers into the equations. The general principle of conservation of linear momentum says that the total linear momentum of an isolated system remains constant. For our system, where both cars couple together and have a common final speed of v sub f, this means that we can write the equation shown. When we solve for v sub f, which is the final velocity of the coupled boxcars, we get the equation shown. Now we will prepare to put the numbers for the particular case that we are analyzing into the equation. We must be careful to keep track of the signs of v sub 02 and v sub 01. Because the masses of the cars are equal, we can simplify the equation as shown. The figure shows the equation with the values of the initial velocities replacing the symbols. Completing the calculation, we get that v sub f equals positive 0.20 meters per second. We see that v sub f is positive, which means that the coupled boxcars move to the right. What would be the final velocity if v sub 02 and v sub 01 have the same signs we used, but with their magnitudes reversed? In other words, what would be the final velocity for the values now shown? In which direction will the coupled boxcars move?